So, well, good evening and welcome to Framingham State University's 2021 Science Festival. My name is Irene Porro and I am a director of the Krista McAuliffe Center. I am truly delighted to be the host tonight of one of the events offered from April 12 to April 24 for the Science on State Street Planet Earth edition. The festival this year features more than 30 virtual and some also in-person events with offerings for learners of different age groups, background, and interests. All events, however, are focused on highlighting the beauty of planet Earth and the urgent need to take care of it, starting from our own neighborhoods and communities. I think you may find, well, on the screen and also in the chat, I'll post it right now, is a link to our website where you can find information about all these events. Now, very briefly, a few reminders for how we are going to interact tonight via the Zoom webinar. First of all, again, we will ask you to actually mute yourself if you haven't done it so already. And if it applies, turn your video off for the duration of the presentation. However, of course, as mentioned earlier, please feel free to introduce yourself in the chat. During the presentation, if you have any questions, we would like to encourage you to use a Q&A feature. You can find the button for the Q&A at the bottom right of your Zoom screen. That's really how we would prefer to process any question you may have. If it's an urgent question that is going to help a speaker clarify a point, we will make sure to share it during the presentation. Otherwise, we will collect them and then go through the list during the Q&A part of the presentation. Oh, yeah, I don't want to forget to remind everyone that this presentation is being recorded as we speak. All right, now is time to get started. Today's speaker is Dr. Vandana Singh. Dr. Singh is a professor of physics at Framingham State University and a science fiction writer. Now, as far as her science fiction writing is concerned, she was recently mentioned in an article in the Washington Post, where her book, Ambiguity Machines and Other Stories, was referred to as terrific. So just a hint, you may want to be checking that book. Anyway, whether writing science fiction, teaching, or developing pedagogies to transform STEM education, she's motivated by the creative space at the intersection of multiple disciplines and modes of communication. And for that reason, I cannot wait to hear from Dr. Singh and to see what she has to share with us tonight. So without further ado, here is Dr. Vandana Singh.
Thank you so much, Irene. Thank you to the McAuliffe Center and to Framingham State University's Science on State Street Festival. It's a pleasure and an honor to be here among you. I'm going to start by acknowledging the land from which I'm speaking. The land from which I'm speaking here in Framingham is the original homeland of the Nipmuc tribal nation. And I want to acknowledge the painful history of genocide and forced removal from this territory, and to honor and respect the many diverse indigenous peoples still connected to this land from which I'm speaking. So let me begin by sharing my screen. I have a slideshow. And I like being interactive, so I'm going to try to go relatively fast through all of these. And take not too much time, hopefully, because I'm looking forward to the question and answer discussion. So, so my title, The Unraveling of the World. I'm not sure that there's even one person among us who doesn't feel at this moment that the world is actually in shambles, that things are spiraling out of control. And whether we are talking about forest fires in California or Australia or the Amazon, or shockingly a few years ago in the Arctic boreal forests, or whether we are talking about the increase in drought-prone regions in the US, and droughts in one place, floods in another, that there's something really, really wrong with the world. And among these things, of course, perhaps we don't think about as much is the fact that the great ice sheets are melting after like thousands and thousands of years. The Greenland ice sheet and the Antarctica ice sheet are both melting. We are losing sea ice. And we're in the middle of the 6th mass extinction. And this picture is only half of a larger composite picture. It doesn't even show the insects. But if you just look at mammals, 25% of mammals are threatened with extinction. And while we are talking about the biosphere, consider this terrible news that I came across recently. If you compare in the yellow in this map, the satellite picture shows the kelp forest, the rainforest of the ocean, off the sea, off the shore of California in 2008, and compare that to 2019, it's basically collapsed. And as all this is happening for various complicated reasons, we seem to be continuing to make things worse by, for instance, it's hard to believe this, but in 2020 with the pandemic and everything, global tropical forest destruction was up 12%. So, and of course we are in the middle of a pandemic, and Dr. Fauci famously said in a paper in Cell in 2020 that we have entered an era of pandemics, which tells us that things will never return to normal in one sense, that if we get over COVID, there's another one, another pandemic around the corner, and we may not be as lucky, it may be much worse. So this really feels like the end times. And yet we don't have the luxury to turn away, even however much we might want to. And so, when I started to think about, particularly my journey started with climate change. And that was more than 10 years ago. And I started to think about it and get really concerned. My training is in theoretical particle physics and not in climate science. So I started digging into the basics of climate science and thinking, how do I teach it in my physics courses? And this led me to questions like, all these crises that are happening, what's happening? What are the causes? How are they related or interrelated to each other? And crucially, what can we do about them? So my own journey of exploration. So this talk is going to be partly my personal journey and partly some things that I discovered and learned from people. I started with researching and teaching climate change in my physics classes. And my early experiences of teaching were actually rather abject failures because although I was able to convey the basics of climate science as they intersected with the physics course, I had hoped to inspire the students to action. And I realized that actually my students were being pushed into despair and hopelessness and feeling burdened by the knowledge that I had given them. And they already had a lot of things to take care of in their lives. So in those first couple of years, I felt that, I always tell my students, learn from failure. So I thought, okay, I'm going to take my own lesson to heart and learn from this. And so that sent me to journeys and an ongoing journey of exploration that I'm continuing with. I went to Alaska, I talked to communities, and ultimately I was led to this question, to ask myself, what is it that the earth is telling us? We are very quick to like roll up our sleeves and say, okay, here's a solution here and here's a solution there, or this person or technology or this group or whatever is going to fix things for us. But I wanted to like put my ear to the earth and try to listen to the crisis as a teacher. What is it teaching us? What is it telling us to do? What challenge is it giving us and asking us to rise up to? So as I did that, my first exploration was in April 2014, where here I am standing at the edge of the frozen Arctic Ocean, where you can see in the background of the picture, the glittering cracked sea ice, which is the frozen seawater floating on liquid water. And this is close to the town of Utqiagvik in northern Alaska, where most of the population is native Inupiaq peoples who have lived in the area for thousands of years and depend on the land and depend on the ice. And while I was there, and of course, while I was doing my research preparatory to the trip, I learned about the rapid melting of the sea ice. So this frozen seawater that extends from the shore in winter for several miles out into the ocean, under which there's liquid water, that ice is melting back at a rapid rate. But what I want to share with you today is less data than some stories that illustrate what the data is telling us. So here's a story that I heard when I was over there. And this I heard from a geophysicist at the University of Alaska at Fairbanks. And he said that about 30 years ago, when scientists went into the Arctic, into North Alaska to study sea ice and ecology of the region and so on and so forth, scientists went with what we usually assume as our that this is our approach. Science is tells us what we need to know and all of that, and a kind of unconscious arrogance perhaps. And he said that when they went there, they had a native elder who led them onto the sea ice. So if you look back at the picture I showed you, so look at the shore ice over here is over land and it's smooth. And then where the currents can break up and cause cracks in the ice and cause these little cracks and the glittering surface, that's where the sea ice is, the frozen seawater on top of liquid water. So imagine him leading this expedition of scientists some 30 years ago, this native elders, leading them to the edge of the ice, far out in the distance, like maybe a couple of miles at the edge of the liquid water. And they're setting up camp. And this is beautiful day. The sky is blue. Not a wind is stirring. There's a major meteorological office that was later set up in the area, but all the instruments were basically saying that the weather is perfect, nothing to worry about. Scientists are unpacking. And then suddenly the native elder says, it's time, guys, we got to pack up and leave right now. We got to leave right now. And they didn't believe him, but there was something about the urgency of his voice that compelled them to obey. So they started packing their stuff and kind of grumbling and looking at each other in puzzlement. And then they began to walk back. And he kept hurrying them, saying, hurry up, we got to leave the ice right now. And they walked all the way from the far shore, the edge of the water, up to the shore ice. And as they did, there was this deafening crack, and the piece of ice on which they had intended to set up camp broke off from the shore ice and floated off into the Arctic Ocean. Now, 30 years ago, there was no Coast Guard presence in the region, and even now it's fairly minuscule. So if you were sitting on a piece of ice that was floated off into the Arctic, that was it. There was no way to find you, So he saved them from disaster. And so this story stayed with me as I talked to native elders, as I talked to scientists, and as I talked to native elders who were scholars and scientists. It was a fascinating conversation. So then I started to think about the places in the world that are most vulnerable to climate impacts, and the societies and the peoples who are most vulnerable to climate impacts. And that led me to another place, to India, in fact, which is also very climate vulnerable, and for a multitude of reasons. Now, don't worry about reading all those bullet points. Those are key findings from a recent last year release of climate assessment in the Indian region. But essentially, the region is vulnerable for a couple of reasons. One is that India is was formerly colonized nation and has a large population of very poor people, and they don't have access to infrastructure to deal with climate impacts. So that's one reason for vulnerability. Many of these people spend most of the time in outdoor laboring conditions like farming or other kinds of labor. And also, as you know, the Earth's temperature is rising. So the regions of the world that are already hot are projected to get hotter. And in some places, they're expecting that under the so-called business as usual scenario, there'll be fatal killer heat waves, where if you're out for more than 5 hours in the sun, you're going to die. It's that bad. Okay. So I wanted to look at a vulnerable community in India, and one of the poorest states is the state of Jharkhand, shown here in red, where climate is expected to, and is already making an impact, the change in the climate with decreased rainfall, decreased dependency on the rainfall. So although rainfall is projected to actually increase, the variability is also increasing, which is bad news for agriculture. And there's already a lot of people who simply live through subsistence agriculture, and that's their only source of livelihood and of food. And temperature rise, it's already undergoing heat waves and so on and so forth. So I wanted to see another place in the world where the people are particularly vulnerable, and which is another ground zero location for climate change. So I had the incredible privilege of talking to people who lived in the region. So if you look at the woman in the red and white outfit, her name is Parvati. She is a villager who has been living in the region in Jharkhand that used to be heavily forested. And through a friend of mine who works with them, I got to talk to her, extended conversation with her a couple of years ago, and learned her story. And her story is one of where she starts out talking about a forest that extended unbroken as far as I could see, thick, heavy subtropical forest filled with wildlife, including tigers, where the summers weren't so hot, where the temperatures didn't rise as much, where the water table was basically secure, so that there was enough water security and food security. And so about 20 years ago, Parvati, who already had a difficult life, she's lost, for instance, a child to snake bite, uh, and does not have access to the things we take for granted. Like just to talk to me, my friend had to take her 5 kilometers away to where someone had a cell phone. So, someone who does not have access to the privileges that we take for granted. So about 20 years ago, when she started noticing changes, but also changes due to destruction of the forests, massive deforestation, which actually has had an incredible uptick in the last 6 years, where swathes of forest were cut down for development projects, for mining, for quarrying, for building roads, for building modern townships, and so on and so forth. And they started noticing rising temperatures and the water table going down, and their own forest dwindling, because the remaining forest, there was increased pressure to use the wood and to use the plants and so on from the forest. So she and a bunch of women in the village got together 20 years ago and decided that they were going to do something about it. And so they started patrolling the forest at dawn. They shooed off people who were potential loggers and people who were taking anything but dead wood from the forest. And even though none of these women have had a day of formal education, they knew because of living next to the forest, they knew that a healthy forest is one with greater biodiversity. So they dug ponds so that animals would have a source of drinking water. And the streams that were emerging from the forest and going out into the desertified landscape and then drying up, they built mud and stone check dams with their bare hands to keep those streams in the forest so that the water wouldn't be wasted. And so through their nurturing of 20 years, this forest has actually regenerated. And although there are no tigers, tigers being a very, very endangered species, other species have come back, water table has risen. And one of the most amazing and inspiring things about talking to Parvati was how ebullient she was, how undepressed she was, despite the difficulties of her life, and how positive and confident she sounded, and how she told me with so much pride that the water table has risen, the village pump is working, and that she's lucky because she only has to walk a kilometer a day to get her daily water supply. So, so this is the second story that I want to tell you. And I have learned from many, many, many communities around the world about what the earth is telling us, and from the earth itself. And also, I must acknowledge my students who have been my best teachers as well. So through all this, I had a number of insights. And one is that it really made me listen to the problem and try to see what is the problem trying to teach us before we figure out that, oh, we know what to do, we can fix it, right? And so what I wanted to know was, what are the key characteristics of the problem? And if our solutions, if our approaches don't actually entangle with the key characteristics, then we are not solving the problem. That was one thing. And the other thing I found that was really interesting and common to both situations, Alaska and Jharkhand, India, is that both of these places had suffered from colonialism and had suffered from from the people being marginalized, being at the bottom of the power pyramid. And therefore that made me recognize, and as a physicist, we don't study these things. So I leaned a lot on social scientists and political scientists and so on to learn about these things. This is a painting by a friend of mine called Inequality. Michelle Gutlove is her name. And this shows us that this reveals how we live in pyramidal power structures, where there are few people at the top who control and manipulate all of society and build structures that maintain their power at the apex of this pyramid. So, so from Alaska to Jharkhand, some of the lessons I learned that I felt the crisis was teaching me are these. So one is that the climate crisis spans enormous spatial and temporal scales, that it's both simultaneously local and planetary, and that history matters, that what we do now, for instance, is going to affect generations of humans in the, for thousands of years. But also what we are now is informed by Earth history and human history. So every scale of time and space matter, and how they interact is really, really important. Because even though we might talk about global average surface temperature and how we should aim for 1.5 degrees C instead of 2 degrees C and all of that good stuff, the action itself is at a local level. And at the same time, we have to be keyed in and woven into the planetary level. So all of this matters. The other thing is that, as you can see from these two stories, climate is an inherently transdisciplinary issue. And yet it's still taught as though it was purely a scientific technological issue. And that's why we often see people simply talk about scientific technological solutions to the climate issue. And yet you can see from my two stories and two examples that we cannot look at climate in isolation from other environmental issues, from this model of development that compels us to raise down forests, from social and economic power structures, and it's entangled with all of these major systemic problems. So we cannot just say that climate is a scientific problem alone, or a social problem alone. It's a mixture of all of these things. That was one major lesson. And then there was another one, that the climate system is a complex system. And there's a history, there's a definition of what a complex system is, which I'm going to go into a little bit later. But here, a complex system is one in which each subsystem interacts in non-trivial ways with other parts. And simple linear causality doesn't always apply. So, in classical physics, for instance, we say that, okay, if you have a mass here and I exert a force on it, it's going to do that. That's simple linear causality. But in complex systems, causality doesn't manifest in that simple way. And so if you think about a complex system as though it was a simple one, you're going to be kicked in the teeth with some surprises. So, and then finally, of course, central to the climate problem is the issue of justice, because the two stories and the two places and the people that taught me this, that neither the villagers in Jharkhand nor the Inupiaq peoples in Alaska caused the climate problem. They did not cause it. And yet they are the ones who are suffering the worst of its impacts. And so there are people in the world who actually did not cause the problem or did not contribute much to it. And yet they are the ones who are least able to protect themselves from its impacts and are at the same time at the bottom of the social power pyramid. And among these peoples are indigenous people, people of color, people in the global south, women, and also the young, because young people have not lived long enough to contribute to carbon emissions in large amounts. And yet we are giving them a planet that is severely damaged, and that's not fair. So this is an issue also of intergenerational justice. So, so by putting an ear to the problem, these are the things I learned, and it's an ongoing journey, and I keep learning. So here I want to talk about how the way that we are taught to think in modern global industrial society is actually does not match up with what the climate is teaching us. So here are the things that I just talked about, summarized on the right-hand side of the screen. But how we are taught to think in modern civilization typically is that we think short-term and local. Our empathy is generally limited to our family and friends, or at the most, people who are the same religion or the same race or same nation or whatever. Okay, limited empathetic reach. And our education system is compartmentalized. So in different silos where physicists don't talk to economists or philosophers or people in political science or literature, right? Whereas the problem itself is inherently transdisciplinary. And also we are not taught to recognize and work with complex systems. We are taught to think simply about a world that is complex. So how is that going to work, right? And finally, we live in highly unequal power hierarchies. The voices of the marginalized people are not out there front and center. Even though, like Parvati in the village in India, they often have incredibly important insights to offer us. So no wonder we are in this mess, right, when we compare these two things. So, and I just want to mention a quick note about pandemics, because I'm going to see if there's time to connect up the existence of the pandemic with some of these other crises like climate change. So I just want to quote very quickly from this paper by Morenz and Fauci from last year. These are all quotes. And you can see here how the pandemic is also not a purely medical problem, right? Land management practices are associated with the re-emergence of certain kinds of diseases, deforestation, road building, environmental degradation. And then they talk about poverty, crowding, poor sanitation. So do you see how so many disciplines and so many threads entangle in this big complex problem, the pandemic, which is very similar to climate change and not unrelated to it, as we'll see. And they talk about these are examples of our inability to live in harmony with nature. So let's try to remember that inability to live in harmony with nature. So anyway, going on, what I did through this journey of learning is to realize that, from my perspective at least, I'm not saying that this is the ultimate. I don't have the ultimate answer. There is no silver bullet, right? But from my perspective, there are 4 dimensions to climate change. And from my stories, you've gathered that there's a transdisciplinary dimension, there's a scientific technological aspect, and I want to talk about some of the others as well. And central to these, a kind of unifying theme is climate justice. So what I do in the classroom, and this is not a formal pedagogical talk, so I'm not going to go into details. And this is something that I've worked mostly in face-to-face classrooms. So I don't think I'm ready to say that I know how to do it online, because I just had one really wonderful class actually last fall to work with on this. And I don't know to what extent it was a success, but the approach that I've developed, the framework, I had wonderful students, but I always do. My students are incredible. So the framework that I developed, I want to describe some key features of it. And here's something that I want to begin with. I want to take you on a little bit of a journey to show you what I show my students. And this is thanks to the McAuliffe Center and Mary McDonald, who along with me, we worked on this, and she runs a little show for my students where we have our first exposure to the notion of the Earth systems that comprise our planet and give rise to planetary climate. So I ask students, as I ask you, to look at this picture, which is a satellite image of Earth, and as though you were an alien, and try to look at the features of this planet. And if you had time, I would literally ask you to point out what you see. But with a little nudging, students are very quickly able to kind of come up with the way that Earth scientists classify the Earth systems. So for instance, we see the biosphere, the Amazon rainforest, we see clouds, that's the atmosphere, we see the oceans, that's the hydrosphere, and so on and so forth, right? And then we see solid land, the geosphere, and so on. And then we say, okay, right now in this picture, we don't actually see any major evidence of human activity, okay? So how do we see the human impact on our planet? So we then look at the Earth at night. And I can't show you the equivalent pictures that we'd see in the planetarium, because those are incredible. So these are just pictures I took from NASA. And you can see the human impact very clearly on the planet when you look at the Earth at night, different parts of the world. So as we look at this, I ask students to hypothesize, why is it that some places have bright lights and others don't? And so after a while, we come up with this initial hypothesis that this must be related to population density. Wherever we have more population, you have more lights. And we say, okay, just as we always do, we test our hypothesis. And so Mary then overlays a population data on top of the globe. And then we see that our hypothesis is actually true for some parts of the world, but not true everywhere. There are regions of fairly high population density that are not brightly lit. What does that tell us? That tells us that the human impact on the planet is not even, that some people do not have access to the benefits of modernity that we take for granted, and do not have the lights to turn on at night, do not perhaps have electricity at all. And so therefore, this allows us to interrogate one of the terms that scientists have come up with recently, which is the anthroposphere, which is the 6th subsystem of the Earth, because now humans, according to the scientists, are of a geological scale force on the planet and the planet's climate. And so they say that, apart from the hydrosphere, the geosphere, all of those other subsystems of the Earth, we should also have an anthroposphere. So this picture, which reveals inequality right away, tells us that the anthroposphere is actually not a very accurate term. And so we settle for something that is not perfect, but better than that. So let me go through this, this picture that we work with. So instead of anthroposphere, which we put in quotes exactly because of that reason that I just described, we say modern industrial civilization, which is a little fairer. It's putting the blame more fairly where it belongs. So, and then we point out that marginalized human groups are actually not as responsible or responsible at all for the kinds of crises because they don't have as much impact on the planet. And therefore, climate is an issue of justice. So we talk about that. And so, and then I introduced three large concepts. And I'm going to go through these really quickly. And I'm going to try to encourage you to think about that, not just through hearing me and watching the slides, but through our bodies. So, I wish we could do this face to face because then it would be much more, we could do a real embodied exercise. Okay, so there are three large concepts that bring in the essence of climate science because, in a physics class, I have to do other things too. I can't just teach climate science, right? And yet, at the same time, these are not just about science, as you'll see. So the first one is one of balance and imbalance. So this is a picture a graph that students look at, which shows the carbon dioxide levels in our atmosphere for almost the last million years. And you can see it goes up and down a lot, but really doesn't go above 300 parts per million, and then it shoots up. And it starts shooting up around the late 1700s or so, at the start of the Industrial Revolution, where in the West, coal particularly was being burnt on a large scale for the first time. And as you might recall from chemistry, C plus O2 is CO2. So that's a simplified version of hydrocarbon combustion. And so we have more carbon dioxide in the atmosphere, and carbon dioxide is well known as a heat trapping gas. So we look at these ups and downs, and if we were able to expand the scale, you'd see that for several hundreds or thousands of years, the carbon dioxide levels stay more or less constant, and then they change. So Earth's own almost 5 billion year history, there have been conditions of balance and conditions of imbalance due to natural causes. But the one we are in the middle of today is because of modern industrial civilization. So what does that look like and why does that happen? I'm going to have you recall what you might have learned in earth science, I don't know how long ago, the carbon cycle. The fact that the carbon atom actually circulates through the various Earth subsystems. So all we need to know here is that if you think of the atmosphere like a box or a bathtub, and all the carbon sources, everything that adds carbon dioxide to the atmosphere as a carbon source, like a faucet that you turn on to fill your bathtub, and everything that takes out carbon dioxide from the atmosphere as a drain that from which you remove water. Okay, so carbon source would be, for instance, us breathing out. Respiration creates carbon dioxide as a waste product. Why doesn't CO2 level in the atmosphere shoot up immediately? Because green plants draw it back in through photosynthesis. And also oceans have a capability of absorbing some carbon dioxide. So carbon sources, carbon sinks. And as you can see, if the carbon sources are adding CO2 to the atmosphere just as fast as the sinks are removing CO2 from the atmosphere, we are going to have a constant amount of carbon dioxide in the atmosphere. Just like if you open your faucet and your drain is functioning and they're both adding water in one case and removing water in the other case at the same rate, then you're going to have a constant level of water in the bathtub. So from this is what we'd call a condition of balance. And where you have constant CO2, other things remaining the same, you're also going to have steady temperatures, okay? But when you add new carbon sources, like we dig up fossil fuels from deep inside the earth, where they don't participate in the short or moderate term carbon cycles, where they're just away from from the short-term and moderate-term carbon cycles, and we're pulling them out, burning them, adding new sources of carbon. At the same time, we're cutting down forests and destroying the ocean ecosystem, and therefore undermining the sinks. So is it a surprise that we are in a state of imbalance, where the carbon dioxide level is shooting up? So that's just one example of imbalance in the climate system. There are others also. This manifests as an energy imbalance in the earth as well. So rising atmospheric carbon dioxide and then destroying the sinks, right? So, and then we go into questions of who's responsible, and And we look at it by country and so on. And there's only one thing I want to point out here, because I'm trying to go fairly quickly through all this material without losing the essence of it. Look at the income level. The richest 10% of people produce 50% of the individual consumption-based contribution to fossil fuel emissions. So, and this has been called climate apartheid, because literally most of the poorest 50% of the world's population produces only 10% of the emissions, and they are the ones suffering the worst from it. So the super rich are super responsible for this crisis. And the richer a person is, and if their lifestyle reflects that high energy intensive lifestyle, the more they're contributing to the destruction of the planet. And of course, by organization as well, there are only 100 super companies that have a kind of tentacle-like hold over the earth and its economy, and that's another issue. So as we look at these subsystems that are being pulled out of balance by the activities of modern industrial civilization, we ask ourselves, so what state are we going towards? And so if you look at this picture and you look at the big circle, which represents the earth, but it also symbolizes a boundary beyond which there is an imbalance. So think about balance in this way. Like, and here's the bodily example I'm trying to talk about, although I don't think you can really see it. But if you want to stand up and try this, go ahead, make sure that you don't fall over though. If I stand on tiptoe on one leg and I try to balance, I have a certain resilience. Like I can sway back and forth without falling over. But you tap me a little, give me a little bit of a push. It doesn't even have to be a big push. And I go into this state of imbalance until I reach a new state of balance, which is lying on the floor, which is not what I want, right? So what is it that anything that is in balance, there's a limit or a boundary beyond which it goes into imbalance. And that boundary need not be a sharp one. It can be a gradual boundary. But nevertheless, there's some kind of threshold or thresholds we have to cross. And that's the idea of planetary boundaries, which is really, really important and central to understanding our climate problem and the other related problems. So this is research from Stockholm University's Resilience Center, where the scientists there have identified 9 planetary boundaries. So in other words, what they're saying is that we can't do whatever the hell we want on this planet because they're natural processes that keep a certain balance condition that is conducive to human civilization and the biosphere. And among these natural processes, as you can see from the slide, climate change is named, biosphere integrity, having enough biodiversity, that's a key part of a healthy planet, and so on. Among these, any violation of even one of these planetary boundaries is actually going to wreck this system, because all of them are interrelated and highly coupled to each other. So even if we violate one of them, we are threatening the human civilization and the biosphere. And right now we have crossed 4. Okay, so there's biosphere loss, there's climate change, there's also, well, I'll show you very quickly, I won't explain these, but the nitrogen cycle, for instance, doesn't get much press compared to the carbon cycle, but it's in massive imbalance. And then of course we are in the middle of a mass extinction, and you can see this by looking at the biomass, the relative biomass of humans and our livestock are the orange and blue in this chart. The mammals, the wild mammals, that is, are this thin little gray portion. And this is absolutely shocking. And when you look at the fact that the UN had a very sobering report in 2019 that about 1 million animal and plant species are under threat of extinction, many within decades, more than ever before in human history. There have been natural extinctions in our planet's history, but this is modern industrial civilization. Okay, so this is pretty sober. Biosphere integrity is being lost as we speak. So, oops, hang on a second. Let me just go back to, I don't know if you, I have to stop sharing and reshare for a moment. Just ran into a bit of a glitch. Okay, so let me go back to the slide where I was. Sorry about that. So, yeah, we went through this, we went through here. All right, narrowing in, here we are. Okay, so if you look at just the climate part of the planetary boundary, where we are headed with so-called business as usual, where we don't do anything about climate change, is essentially that we're looking at a 3 degrees Celsius temperature rise by the end of the century, at least. and the so-called safe limit, where safe is in quotes because of the fact that this would be very, very difficult, but we could potentially heal the Earth, is 1.5 degrees Celsius global average surface temperature rise compared to pre-industrial times. We are currently above 1 degree Celsius, so there's not much more room. And this beyond 1.5 degrees would be catastrophic. And we are currently beyond business as usual. And unfortunately, if you notice the number of right-wing governments around the world, the number of totalitarian governments around the world, connected to massive destruction of natural resources. Look at the destruction of the Amazon, and India too, some of the most historically epic scale destruction of forests is going on right now. So, so we've clearly are in a process of violation here. And when we look at the underlying roots of our crises, instead of just looking at the surface, we see that it's these power structures that benefit a few at the expense of people and the planet that are really at the heart of the problem. And these power structures, of course, through their cultural hegemony, also affect how we think about the world, what we think of as a good or successful life, how we think about recreation or jobs or anything like that. They create the socioeconomic structures that serve them, in which we are all enmeshed. And this economic paradigm is focused on endless exponential growth, a continued devouring of the Earth's resources, even with green energy. So for instance, you might have heard about electric vehicles being the thing that we need to have, one of the necessary technological changes we need to make from fossil fuel powered, gasoline powered vehicles. And that's true, we need them. But people are looking at, the projection is for 230 million electric vehicles on the road by 2030. And in order to get the materials for the batteries for these electric vehicles, we need cobalt, we need nickel, for instance. There are limited supplies of these, and there's political issues as well. You know what the International Seabed Authority is doing as we speak? They're looking at regulations for mining the deep sea. In an ocean where we are already seeing massive collapse of ecosystems, they are now planning to mine the deep sea to feed the green energy revolution. Techno billionaires like Jeff Bezos are talking about going to the moon to mine for nickel and lithium and all of these things to feed the green energy revolution, to save the world from climate change. All right. And if we only focus on climate change alone, maybe that makes sense. But if you look at the fact that we have at least 4 planetary boundaries that are in a state of violation, then we have to rethink that thinking. And so part of this is a kind of paradigm blindness, where we cannot see beyond the way we look at the world. Our frameworks themselves are messed up. And since our frameworks are determine how we think about the world, if they're messed up, we're not going to be thinking the right way. So we see problem shifting, we see denial, of course. We also see co-optation, and we see false solutions. So the Planetary Boundaries framework teaches us one major lesson from it is that if we only focus on our carbon footprint and other things like the Sustainable Development Goals, many of them are well meant, but they also include economic growth, so they're very contradictory. And then if you're only thinking about the Green New Deal in the US and not seeing how the environmental impact of new technologies is outsourced to the rest of the world, not thinking and connecting to the planetary level, then we are going to be in trouble. So, let me see, I'm going backwards here. Okay, so I want to quickly introduce one quick note here that along with carbon footprint, we need that concept, but it doesn't tell us the whole story. What's more useful along with carbon footprint is this notion of material footprint, which takes the total mass of construction, minerals that are mined, and the biomass that is cut down, for mining and all of those things, and compiles them together. And that gives a truer picture of where the world is headed. Because green energy or not, we are increasing our material footprint every day, and it's increasing at an exponential rate. Whether you're talking about water use, metal production, plastics production, and of course, it's creating enormous amount of wastage. So, which is why when we look at our socioeconomic system and look at how this exploitation is causing the problems, we have to ask ourselves, who is benefiting, who is losing? Why are we lending ourselves to this system that is so rotten at the core? So the Planetary Boundaries framework is very important. This Metaconcept is very important because it clarifies that we're indebted to natural cycles and processes. It makes it clear that climate change is only one of multiple crises, and if we focus only on climate change or only on any one of these without looking at how they entangle together, including pandemics, I should add that, then we are going to lose the battle here. And it shows that the social is always entangled with the scientific. So the third meta concept that I want to quickly introduce, and I'm going to glance at the time here. All right, so I'm going to try to go real fast here and then wrap up, is to recognize that we are not taught to recognize what is called a complex system. What is a complex system? A complex system is one that consists of parts, just like a simple system, but the parts are not clearly predefined. And I'll give you an example which will make more sense. And the other thing is that in complex systems, the parts interact strongly, and the interactions are just as important as the parts. So as Aristotle said many thousands of years ago, the whole is greater than the sum of its parts. So we cannot understand a complex system solely on the basis of breaking it down into parts and understanding what each part does. So if we look at complex systems and try to figure out what they are. So let me give you some examples of complex systems, like our nervous system is a complex system. The global climate is a complex system. Human social systems are complex systems. So all of these are made up of different parts, but they interact in ways that are not obvious. And you'll see examples as we go further. So some things we know about complex systems is that they often have complicated feedback loops, which can exist in simple systems, but in complex systems, they play a particularly important role. And so their behavior is not straightforward. It is actually often has surprises in it, unexpected things. And their subsystems can also be complex. So I'll give you just one example from the climate. This is called the ice albedo feedback. And this is relevant to the two stories I told you, set in two different parts of the world, Alaska and India. So in the frozen Arctic Ocean, where the ice is not very thick and underneath it is liquid water, when the ice melts, it leaves in patches of open water. And you know that ice is shiny, which means it reflects, in fact, globally, icy regions of the world reflect back into space without absorption about 30% of the sun's incoming energy. So they act like Earth's air conditioners in a sense, because that 30% is sent back into space without being retained in the Earth system. But water is darker than ice, and water tends to absorb sunlight and retain it in the sun's system. So if you warm the Earth and you melt the northern sea ice, okay, remember the northern ice cap is basically floating ice on the ocean, and you leave patches of dark water, they're going to absorb the sun's light and heat, and then through a process called the greenhouse effect, enhance the temperature rise and cause more ice to melt, which causes more open patches of water, et cetera, et cetera. So you see, this is a vicious cycle, and it can accelerate the climate change. So therefore, they're feedback loops whose behavior is not linear. And therefore, it's only after looking at the problem complexly that we can understand that there are actually connections between what happens in the North Pole and what happens in a place like Jharkhand in India, or for that matter, what happens in Massachusetts. Could a heat wave in Massachusetts or an especially cold winter in Massachusetts, could it be unrelated to what's happening in the rest of the world? Well, the only way we know is by tracing the complex causal links between these two things. And in fact, it turns out that that because the ice caps control global temperature by flinging back 30% of the sun's energy into space without absorption, when the ice caps melt, that disturbs the entire planetary climate system. So indeed, those connections are there. We're just not taught to see them. How many times during the day do you think about the Arctic, right? So without going into too much detail, I just want to point out that when you have these connected systems across the Earth, they complexly connected systems with complex causal loops between them, then you can have what are called tipping points, where the entire Earth system essentially changes its state to another one, where you don't have control anymore, where you can't fix anything because it's out, it's spiraling into another state too fast. So, and we won't know, unfortunately, whether we've crossed a tipping point until we cross them. So these multiple dimensions of climate change with justice at its center, I'm not going to talk for too much longer, I think. I'm going to go quickly through these slides. I wanted to talk a little bit more about the epistemological dimension, which traces the historical roots of how and why we think the way we do in modern industrial cultures. But I'm going to skip that. And if there's questions, I'll point it out. But very quickly to note that the way we think is actually tied into the history of my field, the field of physics, and particularly classical physics or Newtonian physics. So there's just one quick example I want to give you about a problem. There's a story from Borneo in the 1950s where there was an outbreak of malaria. And we know malaria is carried by mosquitoes. So the logical thing was to go straight, shoot for the goal and spray DDT, and of course killed the mosquitoes and controlled the malaria. Well, that sounds like a good plan until you realize that this is ecosystems are complex systems, and other weird things started happening, like roof collapse and outbreak of other diseases that are pretty bad as well. And then only later scientists traced the link to DDT. That, for instance, this is what happened. And I'll just click my way through this so you can see how all of these are connected. And this is really, really fascinating to see. So this is an example of what is known as domino causality, which we don't learn about, right? Even though the world is full of like complex systems. So anyway, so quickly going through this, talking about the justice issue. And also I want to point out that one of the things we do in the classroom, and I'm part of a collaboration with Dr. McMakin in the Department of Psychology, where we're looking at student reactions, and students share with us how they feel about the climate crisis, because our emotional reaction is ultimately what stops us or inspires us to do something about it. And if your emotional reaction is paralyzing despair, you're not going to do anything about it. So we make time in the classroom to actually foreground our emotional reactions and work through them. And I've done things like, invite an environmental poet to do a little poetry workshop after we learn about climate science and so on and so forth. So I'm just going to very briefly mention these things. And then just to summarize everything I've said, this is essentially the still developing framework. And the next stage that I'm at is to really learn from communities and to ask ourselves what kind of future we want. Do we want a future that's dictated by the super rich, which has caused the world to come crashing into this state that we're in? The upper left picture shows us a luxury bunker that the super rich have built in Germany, but they're also here as well. They're building luxury climate bunkers and also pandemic bunkers, which are guarded by armed guards because they expect people like you and me to rise up and revolt, so they're afraid. But anyway, do we want to continue a future dictated by the super rich, or do we want to take inspiration from people who are working on the ground despite incredible odds to try to do something to revive our planet and its life systems? So again, I'm not going to talk about solutions, except that this is part of ongoing work. Again, arising in the classroom and learning from my students when we look at different so-called solutions and discuss what really would be a good solution or solutions. There's no simple answer to a complex problem. And always recognizing the power hierarchy and the need to resist power, not only on the ground as these indigenous people are doing, but also epistemologically, also through the way we conceive the world. And so to recognize that there are actually thousands of experiments around the world. You don't hear about them in the main news sources. Thousands of experiments in alternate ways of living. This particular picture is from a website in India that's maintained the records of these stories, but they are worldwide. And there are new ideas coming up, recognizing that current economic theories of the 20th century are just so 20th century, right? We need new ways of thinking with the new knowledge we have, as well as the old knowledge that comes from indigenous epistemologies that we desperately need to learn more about. So, I'm going to stop here with this slide, and thank you for your attention. And I look forward to hearing your thoughts and questions. Thank you.
Well, thank you, Vandana. This has been, as always, very highlighting. Every time I hear your presentations, I get deeper into some aspects of them. But I wanted to remind everyone, and this is the first of 5 presentations that we are calling thought-provoking calls to action. And I think we don't need to further explain why you actually are the person who opened this series. I want to ask everyone who would like to ask a question to type it in the Q&A if possible. And we are trying to, oh, thank you, Larissa. I already saw yours. I mean, the first question that we already had during the presentation was about the sustainable development goals. And Larissa was asking if you could elaborate a bit more about why the sustainable goals, do you think they are an inadequate and false measure?
Well, I should thank you for that question. It's a very important question. I think there are many good things about the Sustainable Development Goals, but they're inadequate in the sense that they actually represent a compromise after a lot of debate and discussion, and so they have contradictions. So, for example, you have, I believe it's sustain. So, for instance, you have the goal number 8, if I remember correctly, is the one that is about economic growth. And the thing is that you can't have economic growth and a sustainable planet. It's just not possible. And I have a whole paper that I've co-authored with a climate physicist on that. That's coming out in a UN volume, actually, UNESCO volume, about that physical law as well as mathematical logic actually prevents us from reconciling economic growth as we conceive of it now with sustainable development. And the material footprint notion that I introduced goes partly to answer that, because if you keep thinking about growth in the same way, then no matter whether you have, whether you are talking about green energy or whatever, you're going to end up in like violating planetary boundaries in some way, and also hitting certain physical limits. So the second law of thermodynamics, for instance, puts hard limits on efficiencies, technological efficiency. So you might, for instance, make a car 80% efficient, but no more. And right now, cars are usually between 20 to 40% efficiency. I think it was big news when Mercedes announced in 2017, I think, that they had reached 50% efficiency on their cars. So efficiencies are limited by physical law. And so you can't, and even for the sake of argument, let's assume that you have a 100% efficient electric vehicle, okay, or anything else. As long as demand is increasing, as long as you are on that same consumption pattern of endless economic growth, you're going to have more and more people wanting those cars or whatever it is, and greater numbers of people, buying stuff that all comes from digging up the earth or exploiting some kind of natural resource, and your material footprint is going to continue to grow, and so then you're going to end up violating planetary boundaries, and probably even the carbon dioxide levels will not be able to be contained. So, so there are many good things about the Sustainable Development Goals, but they are full of, they do have some unreconcilable contradictions as well.
Right. Maybe this is well, it's not related necessarily, but an interesting question as well about the real problem of population. I would imagine means population growth. Why is not population being included in your structure? I'm reading the question.
All right. Yeah, let's think about population. Let's think about the fact that, okay, so firstly, population is important because ecosystems have certain carrying capacity, right? So if a population exceeds the carrying capacity of the ecosystem, then we're going to have trouble. And then we'll see a population collapse, right? It happens. Any biologist, any ecologist can tell us that. But let's also look at another statistic. Let's look at the percent of the United States is 5% or so of the world's population and consumes about 25% of the world's resources. So if we look at population alone, then can we really say that that's enough? I mean, like population and inequality and the socioeconomic structure in which we live are intimately tied. And yes, population is an important issue, but population is intimate. You cannot look at it in isolation. And it also often becomes an argument for the developed world to shrug off its historic responsibility for creating the climate crisis. But we do have to deal with it. And how do we deal with it? I'll tell you a very simple way that has been shown again and again to work. And that is to invest in the empowerment and education of women. Wherever that has been done in the world, and there's reams and reams of research on that, population has dropped and family health has improved and so on and so forth. So if we invest in the empowerment and education of women, then that is the solution to the population crisis. But again, it's very important to be careful about how we talk about population, because it's the problem is not just population. In fact, the origin of the problem is not population at all. It's inequality, it's colonialism, and it's imperialism. So we cannot ignore those things. We have to look at them as an entangled whole. So yeah, good question. Thank you.
Great question indeed. Let's see. We have a question from Laura, who is asking, could you elaborate on the way our human response to learning about unsustainable systems involves denial and overwhelm?
Okay, that's a great question too. Yeah. So denial and overwhelm. Yeah. So the slide that I kind of rushed through actually quoted the climate scientist Nobel laureate Steve Running, who first proposed some years ago that that learning about climate change is an emotional trauma, because we are learning about, when we go through loss, when we go through grief, then according to the Kubler-Ross scale, we go through these 5 stages of grief, right? And only then can we come to acceptance after going through all these stages. And so he said that it's very likely that when we learn about climate change, that we suffer an emotional trauma, and especially when we experience it. And that's got to be much worse. But even learning about it is an emotional trauma that we shrink away from. We try to pretend that it's not happening. We try to distance ourselves from it, or we try to argue with ourselves that it won't be so bad, and so on and so forth. In other words, go through all those stages: denial, anger, apathy, bargaining, and so on, until we accept the truth of it and then decide that we have to work on it. So in the classroom, for instance, what I've learned from my students is that emotions are real and they're really important. And that unlike what we learn in the sciences, that we throw emotions out the window, we have to take them into account. Otherwise, we'll paralyze ourselves into inaction. So it's when so the experiments that I've done in the classroom, especially involving techniques from the humanities, whether it's poetry or, I mentioned inviting an environmental poet to talk to the classroom, and how, when you get to share grief collectively, and this is particularly a problem in cultures where individualism is a big deal. But even here, we know how to think collectively. We have a history of social movements. So when we share grief collectively, then we can get through it. And then we can be free to act. And again, I cycle through this all the time. There are times when I cannot hear one more thing about biodiversity or species or climate. And then I have to work through it with other people usually before I'm ready to deal with it again. So yeah, thank you for that question.
And another question related to education, but for maybe younger groups, right? Heather is asking, do you have recommendations for how elementary school children can learn more about climate change and how to take action to combat climate change in a meaningful way for younger audiences?
Yeah. Well, I'm not. That's not the population that I have the most experience with. But I have worked a little bit with children, particularly years ago. I used to do science lessons for a homeschooling group, local homeschooling group, where there was a kid age range from 6 to 13. And I think that we have to be careful not to overwhelm the kids with too much bad news without really denying how serious things are. So I would say that, and also it's really important to get away from the notion of individual solutions, that, okay, I change my light bulbs, I buy a Prius, and then I can delude myself into thinking that I've done my part. And actually those things might be necessary, of course. We have to change our lifestyle, but we also have to work collectively. So if we can find ways for for kids, and especially elementary school kids at those tender ages, firstly to connect to nature, to connect to other species, to be able to deal with emotions collectively, to create an environment. Like one of the things I haven't mentioned is that the success of this framework that I'm working on depends deeply on whether I can build a classroom where trust is foregrounded, where students feel they can trust me and each other, emotionally, intellectually, in all those ways. And I think the same applies even more strongly when you have young kids, where if they feel emotionally close to each other, and let's say they feel sad that they've learned about a species going extinct, then let's use song, let's use poetry to help them express that sadness and look around them and connect, and maybe protect the wild areas around them, and then connect that to a global level. We know how powerful young people can be. Look at the youth climate movements. So I think that we would have to really, and I would bow to those of you who are used to, and work with young children, who have much more experience of how to do that. Um, and people say, that, and thank you for that recommendation of the book, Larissa. I've heard about it, I haven't read it yet. But people say that talking to kids about climate change is now, and the other global crises, don't just talk about climate change, talk about biodiversity loss, talk about land system change, the fact that 75% of the land on this planet is basically been taken over by modern industrial civilization. Talk to them about all these issues. But people are saying that this is one of the big talks you have with kids, just like you have big talks with your kids about drugs, about sex, and things like that. Another one is about what's happening to the planet. So yes.
Well, thank you for that question. It allows me also to put a plug for we've been listening to what teachers have been asking to us and parents as well. So for this festival, we actually organize it's actually two essentially, but a presentation that are specific for kids in grade 3 to 5, and the other one 5 to 8. There is one 1 to 3, but it's about the moon, so it's not really climate change. But the other two are specifically to talk about climate change with these younger audiences. And I have to say, I've been completely impressed by the response that we got. I don't have a correct numbers at this point because they keep growing, but as of, a few days ago, we have about an estimated 800 students, and including the first graders at this point. They've been registered through their schools, their classes, to actually attend this kind of presentations. So there is really something, and thank you, Suzanne is putting in the chat the specific links to these events. If there are educators in the audience or parents, know that, again, there are these offerings, and it's just as a starting point for these important conversations. And I used to say one of these presentations is specifically based on a children's book as well, that the presenter is the author of this children's book. I have, and thank you, Barbara, for your comments and also in the Q&A. If Dr. Singh is not able to see that, you see.
I just opened the Q&A.
Yeah, I think it is this point of including the emphasis on importance of empowering women as part of your very comprehensive presentation, and it's just going to make it a little bit longer, but that's okay.
No, I agree, Barbara, thank you for your comments. Those are really important points, and it's very cool that you've been teaching science for as long as you have. I totally agree that that children need to get outside. We all need to get outside, right? Yeah.
But there is one more question.
Yeah,
I know it's actually two and are kind of big, but maybe Vishnu, who is asking, what are your thoughts on the Big Green, and does the Big Green serve the interests of the common people?
Yeah, and does the Paris Climate Agreement serve the best interests of the African countries? Yeah, this is a great question. Thank you, Vishnu, for asking it. It's actually, what I said about power co-ops, right? So we have the World Economic Forum, which represents the 300 top richest companies in the world, including all the fossil fuel companies, basically deciding, for instance, that they're going to save the planet and they have a plan for the planet without any sense of irony, for one thing, and also without any admission that they have it wrong. That they've led us to this place. So there's no real taking of responsibility there, and so that's why we have all these issues. So to your specific point, when we say big green, like when you mean, so there are two kinds of, as far as I know, I'm not trained as an environmentalist, but I have some experience with environmental groups in India particularly. There are two broad kinds of environmentalism that I've come across. One is the more elite kind, where you say, okay, you have to preserve nature, so let's kick out all the people and create these regions where people can't do their stuff, and that's elite environmentalism. And the other kind, which is really the only kind that I believe works, is when the local people are involved in the maintenance of their environment, where we don't have this false separation between people and nature. So for instance, one really good one-stroke climate mitigation strategy, which would also help with biodiversity loss, is to give indigenous people land rights. Because studies show that, firstly, indigenous people are 8% of the world's population and manage about 80% of the world's biodiversity. And also that includes about more than almost 300,000 million tons of carbon, okay? And yet, and in fact, it shows that wherever indigenous people have rights to their land, legal rights to their land, the forests are thicker, the forest cover is thicker, there's better biodiversity and all of that. So one of the things we can do is to give indigenous people rights to their land, right? And yet, that's not on the table in UN deliberations and so on. And think about the fact that the UN has been meeting for 25 years on the climate, and carbon dioxide levels are still going up. Okay, the UN has done some good work in terms of their reports and the biodiversity loss and so on and so forth. But in terms of actually getting to the place we need to be, that has not happened. And we have to think about the fact that that power has the people who are the most powerful, whether they are leaders of powerful countries or they are, like corporate representatives and so on, have a disproportionate amount of influence in these conferences. And it was actually, so the Paris Climate Agreement, for instance, is like a barely like tiny little step, which again does not, and again, it does not challenge growth. It does not look at the roots of the problem. It does not actually put an ear to what's actually happening, what the problem is trying to tell us, what the earth is trying to tell us. It's a fix from within the paradigm that created the problem in the first place. Now, there are many right things about it. We do need a clean energy transition, for example. But how do you do it? The devil is in the details, right? And if you're going to do a clean energy transition on the basis of the same growth paradigm and on the basis of giving the burden of the change to the people who are at the bottom of the pyramid, as France tried to do, right, some time ago, then it's not going to work. So really, we have to be very careful to listen to who's talking and to speak truth to power when it speaks so loudly, because it's not actually going to benefit. When they talk about carbon trading, they're just looking at the problem from within this current growth paradigm, within this economic paradigm. So that's not solving the problem. I think that's problem shifting. That's a kind of, it's worse than denial, because denial you can at least recognize. But this, to most of us who are not experts, it'll sound at first sight like, wow, people are really doing something, and they're not. So that's the sober truth.
Well, definitely, just the beginning of a conversation here. We are not trying to provide an easy recipe to solve any problem, but obviously, as your presentation explained to us, it's not just one action or one new technological solution is going to solve the problem. We have to look at all how everything is connected and the complexity of the problem. But also, I think I want to say we can do it, but we need to put ourselves in the picture, not just to wait for someone else
Right.
to
Right.
find a solution. I think what I hear from you is that we have to listen. We have to watch for those aspects, the devil in the details. We need to be aware of what we're talking about. And again, not just to be here and passive, waiting for someone else to come and magically solve a problem, but be part of a solution with our own action.
Yeah, yeah. And we have to have conceptual clarity for that. So, and that's what I've been searching for, because if we are acting from the right place in the right way, and thinking in this entangled way across time and across space, across the planet, then we are more likely to make some lasting changes.
Right, but I can see we went a little beyond our time, but I think the conversation has been excellent and really empowering in so many ways. I want to thank all the people who participated tonight, and maybe I'll ask Suzanne if she wants to post in the chat again the link to the other, 4 now presentations that are going to be really thought-provoking, and we hope engaging everyone in some kind of action that we think is going to be appropriate for our understanding and our resources. But certainly keep learning, because that's the important place where to start. But so I want to say thank you to Dr. Singh again for another great presentation and for being so inspiring. And we'll be, as far as the festival is concerned, well, we are going to see, I hope, some of you again tomorrow and in the days to come. The festival will last until April 24th. But for the time being, good night, everyone. And see you soon.
Thank you. Thank you, everyone. Thank you, Irene, Suzanne. Good to see you all.